Factoring special products. Earlier in this chapter, we used the reverse of this pattern to multiply binomials. So let's write, for example, if we have x squared and 25, we look at they're both perfect squares, okay? So think about it this way. This is the same as saying x squared plus 0x minus 25. With that being said, we know that 25, if we have 5 to the power of 2, gives us what? 25. So if we have, let's say the number 4, 1, and let's say z to the power of 2, these are all perfect squares because this will be this, wait, not 4 will be 2 to the power 2, 1 to the power 2, and this is z, correct? Let me use instead x so we could be able to. These are all perfect squares. So here, the difference of two square patterns, if you have a squared minus b squared, we're going to have a pattern of a plus b times a minus b. So when you see the negative sign here on this, we're going to have a positive and a negative, which is the sum. Think about the sum and difference special product that we had before when we reversed the pattern, correct? By multiplying. Factoring the difference of two squared. In A, we have x squared minus 25. The format that they want us factoring the difference of two squared is going to be a squared minus b squared format. So if I have it in this format, this is going to equals x squared. Let me write it at the bottom. This is going to equal x squared minus 5 to the power of 2. Now, the difference of the two square pattern, remember, one is positive and one is basically negative, which is a plus and minus. It's going to be x minus 5 times x plus 5. B, we have 4 z to the power 2 minus 1. If I need to write it in this format that they're asking us, we're going to find the difference of the two square. I know that the 4 is a perfect square, which is 2 to the power of 2 gives me 4. This is z. It's already in perfect square. You know, the twos look very similar, so let me do this to the z. To the power 2 minus 1 to the power of 2, which is gives me the same format that they're looking for. So if I have to find the difference of the two square patterns, it's going to equal 2z. My z do not look good. Z minus 1 times 2z plus 1. Now here we have evaluate the product pattern to evaluate the expression. Now we have a numerical expression. That means that everything is numbered. I have 54 to the power 2 minus 48 to the power 2. If you notice here, we have the same pattern. It's a difference of two squares. So we can rewrite the expression in a form that it will be easier to evaluating using the difference of two square pattern, which will be, we know the minus. We're going to have a difference is 54 minus 48 times 54 plus 48. 54 minus 48 gives me 6. And 54 plus 48 gives me 102. These two multiplied together gives me 612. Perfect square trinomial. Here we're going to have a squared plus 2 times a, b plus b squared is going to give me a plus b, all that squared, right? This is just basically we're rewriting where we're normalizing that a it's squared, and b is also a perfect square. They're both going to be perfect square. Then we multiply our a and b, how many? 2 times, okay? So, an a squared minus 2ab plus b squared is going to give me a minus b squared. Again, that means that a and b are perfect squares, and we multiplied a and b 2 times. Why would it be negative? So in a way, the best way I could explain it to you is when you have this positive here, your trinomial has a positive and a positive sign, which will be right here and over here. Now with a minus b squared, you're going to have a minus and a positive. Think about when you're foiling. If we were to have foiled a minus b times a minus b, which is given to us here, we know that L in our foiling is going to become negative and negative, which is in the b here, gives us a positive number, okay? Here we know that b times b, when it's both positive, you're going to still get a positive. So the best method to realize is if you have a plus sign in front of basically b in the trinomial, or a minus sign, you're going to have in plus both positives, and in negative, you're going to have a negative and a positive. So let's work this out. If we know we have, factoring the perfect trinomial, we have n squared plus 8n plus 16. Remember, we know we have a positive and a positive, so that means that my inside is going to be positive, correct? So if I have n squared, which is a perfect square, plus 2 times a and b. So basically, one number multiplied twice will give me 8. I know I'm going to have 2n, which is my given variable. It's going to be 4 plus the perfect square of 16 will be 4 to the power of 2. Now I have the perfect square trinomial pattern, which is n squared plus 4n squared left. Simplified this, we're going to have n plus 4 to the power of 2. So the best method I could think about it, I already know that I have a minus in b. We look at b. A trick that I learned was if b, remember this is a, b, and c from our previous lesson. If I could split my b into 2, okay, 2 will be a times b, correct? If I could split my b into 2, then I'm able to say that I'm going to be able to find the perfect square trinomial. So I know that 2 times 6 gives me 12. So I can cross this out and be left with 4x squared minus 9 and look for my perfect squares, right? So I know that 4 will be 2x times the power of 2. Remember, when you are distributing exponent, you're giving the exponent to every single term inside the parentheses. Minus, and the perfect square of 9 is 3 to the power of 2. So my perfect square trinomial will be 2x minus 3 squared. Now I have solving a polynomial equation. I already know that equation. That means I have that equal sign here. I need to solve for who? For x, okay? Before we had no equal sign, so we had basically an expression, right? Solve for x, correct? In this instance. So we're still going to apply the same method that we've been working. So we have x squared plus 2/3 x plus 1/9 equals 0. So after rewriting the equation, I see that I have two fractions. And I know to get rid of fractions, especially a denominator, we're going to multiply. Use the multiplication. So if I multiply here, I'm going to multiply by 9. Okay, I'm going to multiply each term by 9. Why? Because I know that 9 divided by 9 will give me the number itself. In this case, the number 1, right? And I know that 9, 3 can be divided together. So I'm going to have multiply 9 times 9x squared gives me 9x squared plus 9 times 2 gives me 18. 18 divided by 3 gives me 6x. So for those that forget, you're basically saying 9, a whole number, times 2/3. Write a 1 at the bottom. 9 times 2 gives me 18 over 3 gives me your answer 6x. And we know that 9 times 1 over 9 first, it's going to give me 9 over 9, which gives me plus 1. And 9 times 0 gives me 0. So with this aside, I am now left with a new polynomial, right? So my answer will be, the first thing I said, use the same trick I told you before. Would I be able to divide 6 by 2? Yes, will be 3, right? So I can say that I could cross this out and look for my perfect square trinomial pattern, which I know that 9 perfect square is 3 to the power of 2. X is already squared. So it's going to be 3x squared plus 1 squared equals 0. I'm just writing it in the format of a squared minus b squared. I can say that this is now going to be 3x plus 1 squared equals 0. So like before, we have the 0 product property, which I already know as z. So somewhere, if you have to remember, when x plus a squared equals 0, you're going to have repeated roots and x equals negative a. Here I already know that I have a plus sign. It's given here. That means that I'm going to have repeated roots. Do I need to separate that binomial right there into 2 to work out for x? No, because I already know it's going to be repeated, correct? So if I was to rewrite this for the 0 property product, I'm going to have 3x plus 1 equals 0. I'm going to subtract 1 from both sides, and I'm left with 3x equals negative 1. I'm going to divide by 3. I solved for x. X equals negative 1/3. Factoring the polynomial. So I'm going to be factoring the difference of 2 squares because I already see that I have x is squared and 36 is a perfect square. So remember, I'm looking for a squared minus b squared. So if x is already squared, minus 36 squared will be 6 to the power of 2. To simplify this, I'm going to have the difference of the both squares will be x plus 6 times x minus 6. Number 2, again, I'm looking for the difference of the 2 squares. So I'm going to have, I know that 100 will be 10 to the power of 2 minus m squared. Rewriting this, I'm going to write it down here. I'm going to have the difference of the 2 squares, 10 minus m and 10 plus m. Please note that 10, the 100 is first, so you need to have the 10 first. Remember, it's not the same as saying 5 minus 4 and 4 minus 5. So do not rewrite it. Write it the way you see it. It's the best method I'm able to tell you. Number 3, I'm going to find, again, the difference of the 2 squares. So I know that 9n squared will give me 3n squared minus 4 to the power of 2. I have both n squared. My final answer, I forgot to put the parentheses here, okay, because both of them are given the exponent of 2. So here my final answer will be in the difference of the two squares, 3n plus 4 times 3n minus 4. And finally, we have 16h squared minus 9. Rewriting it in the two difference of two square patterns, I'm going to have 4h squared minus 7 squared. My final answer will be 4h plus 7 times 4h minus 7. So if you really think about it, when you see the minus sign here, you're basically having a plus and a minus in your difference of squares. Evaluating the expression using the product pattern. So again, we're going to do the difference of two squares. In this case, 36, we know this is telling us it's squared, so we really cannot do anything here to rewrite it, but now it's numerical. So when we see numerical, we're able to break this down into 2, right? Which is going to be 3x minus 34 times 3x plus 34. So if you notice, remember you have a negative sign in the middle, so we're going to have a positive and a negative. 36 minus 34 gives me 2 times 36 plus 34 gives me 70, right? 2 times 70 gives me 140. That's your final answer. Number 6, I also see a minus in the center, so I'm going to have a positive and a negative. I'm going to have 47 minus 44 times 47 plus 44. 47 minus 44 gives me 3, and 47 plus 44 gives me 91. So 3 times 91 gives me 273. Number 7, again, I have a minus sign. So I'm going to have a plus and a minus. 55 plus 50 times 55 minus 50. 55 plus 50 gives me 105 times 55 minus 50 gives me 5. So 105 times 5 gives me 525. Number 8, again, I still have a minus sign. So I'm going to have a minus and a positive. Even if you say positive and minus, same thing, because we're just multiplying in the end. So we're going to have 28 plus 24 times 28 minus 24. 28 plus 24 gives me 52 times 28 minus 24, 4. 52 times 4 gives me 208. Factor the polynomial. Number 9. So again, think, can you divide that b in the middle by 2? And we know that 2 divided by 2 will give me 1. So I'm able to work out and look for my perfect trinomial pattern. So I'm going to cross this out. Notice I'm crossing out also the plus sign so that you can see you're left with m squared minus 1 squared. And our final answer is going to be m minus 1 squared. Number 10, can 10 be divided by 2? Yes, correct. So that means I'm able to work this out. This cancels out and I'm left with 2d minus perfect square of 25 will be 5 squared. My final answer is d minus 5 squared. Number 11, again, we have now a is no longer what? A is no longer 1 as before. But we know that 9 is a perfect square. But Can we have a GCF here? Yes, I can factor out a 9 from all this, and I'm going to be left with z squared plus 4z. It looks like 2's. Let me rewrite that one. Looks like a 2. Plus 4. Correct? Because if you think about it, when I distribute, I'm having 9 across. You're distributing 9 across. So I'm able to now continue to look for my pattern. Can 4 be divided by 2? Correct. So that means that I'm left with 9 times z is already squared. Plus, and I know the square of 4 is going to be 2 to the power of 2. Simplify, my final answer is 9 times z plus 2 to the power squared. Solve the equation. I see 0 here, so that means I have to use my zero product property. So in number 1, I still could work out just what I've been doing. Can 6 be divided by 2? Yes, so I could forget about this right here for now. In the end, if I was to FOIL, I'm going to end up back to my trinomial. This is the perfect square trinomial. So a is already squared, so I'm going to have a squared. The perfect square of 9 is going to be plus 3 to the power of 2, which gives me 0, equals 0, correct? So a plus 3 squared equals 0. Remember the previous rule. When our equation is positive, right? In this case, we're always going to have repeated roots. So I'm able to work this out for just one time. A plus 3 equals 0. Subtract 3 from both sides. A equals negative 3. So even if I was to square these out, okay, so think about it. A plus 3 times A plus 3 equals 0. Previous lesson, we knew that it was A plus 3 equals 0. A plus 3 equals 0. But we're continue working it out. I'm going to have A equals negative 3. A equals negative 3. So recall that when we have that positive right over here, we're going to have repeated nth roots. So you only need to work one out, but that's only when you have a positive left. Number 13, we have fractions again, correct? So I already know that I need to multiply everything by 36. I know that I can divide 36 by 3 and still have a whole number, correct? So 36 times w squared, I'm going to be left with 36w squared minus 36 times 7/3 gives me, I know that this is going to give me 36 times 7, 252 divided by 3 gives me 84w plus, this cancels out with this, plus 49 equals 0. And I'm going to continue looking for my perfect square trinomial pattern. So I know that 36 is a perfect square, so I'm going to have 6w squared. And can I split 84 into 2? Yes, by 42 times 2, right? So I'm going to cancel this out, and I'm left with minus, and the perfect square of 49 is 7 squared equals 0. So rewriting this, I'm going to have 6w minus 7 equals 0. Rewriting this, I'm going to have 6w minus 7. I need to solve, looking for the w. So I'm going to add 7 to both sides, and I'm left with 6w equals 7. I'm going to divide by 6 on both sides. My answer is going to be W equals 7 over 6. That's my solution. Number 14, again, I have an n squared minus 81 equals 0. So I have this squared n minus 9 squared, correct? Because 9 perfect square will be 9 times 9 gives us 81 equals 0. But I already know that this is a minus. I'm going to have a positive and a negative. So if I was to rewrite this, my answer will be n minus 9 times n plus 9 equals 0. Okay, so let me take it back a little bit. I know that rewriting this will be n minus 9 squared equals 0. I know, again, I have that minus sign here. I do not have the positive sign like before. So I'm going to have simplified this, factoring out n minus 9 times n plus 9 equals 0. So I'm going to have n minus 9 equals 0, n plus 9 equals 0. Add 9 to both sides. I have n equals 9. Subtract 9 to both sides. I have n equals negative 9. So I go back to the rule that I'm going to have a positive and a negative in this instance. But I already did it based on what? My factoring out.